Hello everyone. Today we are going to learn how SML can help us to accelerate the process of building machine learning model and apply it on a real problem. In this demo, you will learn how to basically go over essential steps in the process, and we're going to review how SML helps us to do that. By the end of this demo, you will learn how to upload data, select targets, go over your data and clean it if needed, train a model, and review the model performance. The problem that we are going to look at today is from the oil and gas industry. And specifically, we are going to build a model to predict the initial production of a single well based on different inputs, such as location, rock quality, well design, etc. In any machine learning problem, our first step is basically to look at the data and upload the data. And that can be done from the datasets here in SML. Under datasets, you can actually have your own datasets and datasets that your teammates shared with you. You can create a new dataset, or you can use any of your existing datasets. In this specific problem, we're actually going to use the gas case. Once you select the gas case card, you're going to go to the upload data step. Our first step in SML, as I said, is to upload the data, and that's what we are going to do right now. Let me quickly show you what kind of data we have. So our data set consists of features and targets in yellow. We have different features that we are going to use in order to predict a target, and that's the idea. That's the goal of building the model using SML. We are trying to find a combination of features and see what is the contribution of each feature into our model in order to basically predict a target. In our case, the initial production. SML is very flexible in terms of the file signature. So you can have as many features as you want and as many targets as you want, and then select it during the process in the SML platform to build your machine learning model. In QRI, we understand that any machine learning problem can have its own data signature. And that's why we created a robust data upload step that allows you to use any data that you have to build the best model possible. As I said, our first step is basically to upload the data. I'm going to drag and drop the file into the platform. Once you upload the data, you can review the signature of the data sets that you have. It's going to tell you what type of features you have. Any additional file you want to upload has to follow the same signatures that you already have in this dataset. After uploading the data to the platform, you would be able to start working on your data. And for that, we are going to create a workspace. Let's give it a name, IP prediction. Once you create your workspace, you would be able to share it with your teammates. This is very, very important because in QRI, we believe that collaboration is a very important step to achieve better results. Therefore, the ability to share data and model gets high priority in our workflow. When you click on collaboration, you can basically add any one of your teammates to be able to work with your workspace. Once you have your workspace, the next step is basically creating your machine learning model. And that can be done by using the new experience. So every experience is essentially building a model, a new model. You need to name the model. You need to specify what is the workspace and the data that you want to work with, and you start creating the model. Our first step, you're going to see here a workflow that has 5 steps. The first one is basically to initial the model that you are going to solve, or basically to model that you are going to build. So since you might have more than one file, and in our case, I only uploaded one file, I'm going to select this file, and this is the file that I'm going to work with. The next step is basically to select the target column. In our case, you can select any column from your dataset to be a target, but as I mentioned, I want to work on the IP, the initial production, and that's going to be my target. Based on the type of the target that we selected, we can define what type of problem we are trying to solve. In this case, regression seems to be the right selection for the problem type. You can also use classification. For a different example, it might be more appropriate. Let's move on to the pre-processing step. Many times, the data is not ready to solve the machine learning problems that you have. Therefore, you want to actually look into the data, visual it, and explore the data better to understand the data quality. In SML, you can look at the distribution of the features that you have. You can look at all of them or maybe some of them and generate the distribution plot. You can quickly review that, try to identify some and detect some outliers and problems that you might have in your data. Here is a good example for outlier. You can also try to look at the feature correlation metrics. This is going to tell you the relationships between the features that you have in one plot. You can try to indicate which features are more correlated to each other, what are going to be at least more important as the first step for your machine learning problem that you are solving. Another step that you can take here is basically to look at the pairwise plot to understand the joint distribution of two features. For example, you can look at the connection between EOR and IP. Try to see if you see any correlation between those two. You can change the color of the scales, of course, based on your preference. Next, we would like to start pre-processing the data in a way that we can use it to solve the machine learning problem that we have. SML is going to automatically indicate what steps needs to be done in order to move to the next step, which is training the model. As you can see here, you need to define the training and the test split. You need to look at the missing data that you have and some categorical data that you need to change in order to be able to solve the machine learning problem. We are going to start with actually removing features that we are not going to use in the prediction. The features that we are removing are actually features that we are not going to have when we are running the prediction for new data. This is related to the flow and the production data of a well. We can also go and look at the features that we already seen that have outliers and remove the outliers from the data sets. There is a long list of steps that you can do here, and SML makes your life very easy by implementing those. You can also use the autopilot, and that SML is smart enough to basically complete the steps that are flagged and make sure that you are ready to move to the next step. You can also review all the steps that SML does, as well as the steps that you have done before. Once you are ready, after pre-processing the data, you can move to the model training. First, we select the model evaluation metrics so we can basically track the performance of your model while we are training it. Then we are going to select different models that we want to run. There are a list of models that you can select here, and you can use the autopilot mode to train the models and run them simultaneously and follow the results in a real time in order to understand how your model are performing. You can, of course, stop at any time your model and basically review the results that you have. The fact that we are using the cloud helps us to quickly run all the models at the same time and review the outcome. Once you are done with training your models, you can move to the next step, finalizing your models. In this case, we actually selected five different models, and you can create different combination of those models, ensembles of models, and try to build one model that is the best representation of what the data is telling you. You can use one model if you want, or as I said, a combination of different models. There are different ways to assemble the models, so that might result a little bit differently from the previous models. Once you are happy with the model that you built, you can basically select the model, and now we are going to the playground. You can look at the model score to start with, just to get a better understanding of how your model is performing. As you can see here, in terms of training, we have very good results, and then validation, when we are actually using all the inputs data, but not letting your model know what the results are and then compare it to that, you're having about 70%. And for the testing, which is the double-blind test, has 80% success. Another good way to look at the performance of your model is to look at the true results versus prediction. As you can see here, if you follow along the diagonal line here, the unit line, this is basically telling you that any value that you are predicting is going to give you pretty much at the same neighborhood of what the real value is for this specific model. You can remove and look only at the training. You can look only on the testing, okay? And the red lines are the 20% error that you have. Another important feature is the basically trying to identify the heavy hitters of the model. What this analysis is going to tell you is what are the features that are very important for your model. You can see here that in order to get, for example, the IP, there is a good correlation with the lateral length and the chalk description. Partial dependency is going to tell you how a specific feature impact your target. So, for example, you can see here that lateral length, as I'm increasing the lateral length up until a specific point, it is actually going to increase your IP. But then above this point, I don't see such a huge increase. This is a very important information that you are getting from your model. Quantify uncertainty is very important to identify the risk that you have in when you are predicting. We're going to run it very quickly. And what this is going to tell you is basically the prediction and the associated risk that we have. As you can see here, the prediction is the blue line. The true values are the green stars, and the uncertainty band is basically the gray area. This is the 80% confidence interval with your prediction. Once you are happy with your model and you are able to basically review and understand the relationship between the features that you have and the target, you can actually create a prediction. Making a prediction can be done either manually at a platform or using the same file that you have without a target while uploading the files. Let's just go to the manually edit, and you see a set of inputs, which basically are the same inputs that you have for your input files. You can make a prediction, and you are going to see what is going to be your IP, including the distribution of the values that you're going to have. You can either make another prediction or move to the next step. You can also generate a report that is going to review the entire process that you've done, including the model that you have. Let's just quickly create a PDF report here. It's going to take you some time because it's basically going to review all the data that you have, the pre-processing, training, evaluation of your model, and explanation of your model. While we are generating the report, I would like to go and just show you some more steps here. One of them is generating the API keys. That's going to help you basically to output your model and call it from different software, Python, MATLAB, JavaScript. You can also review the model that you have what type of data you use, what steps you've done in the pre-processing, and what is the model that you are using. Our report is ready, and we can download it here and review it in a second. As you can see here, the report is ready. You can quickly go over the data that you have. See the different features that you have, different distribution before and after the pre-processing. The training, the validation, the feature importance, the different correlations that you have in the features, and the uncertainty associated with your prediction. When you are done with all the steps, you can publish this experiment with your teammates. They are going to see the model on their side.